So I ended that one short by mistake, so I will just pick up here with part 2 lecture on chapter 6, and we're looking at Jeremy Bentham, and we're talking about the philosophy of utilitarianism, which is a philosophy that you try to get the greatest good for the greatest number of people, and they believe you can measure benefit in some kind of a measurement like utils, and then pain, things you don't like, discomfort, are disutils. And it's kind of a form of calculus where you try to, again, add up all the utils you get, subtract all the disutils, and try to get the greatest number of positive net utils. It may seem kind of hokey, but this is doable in the sense that we can actually give util measurements to various types of activities. For example, if I tell you that, if you like Starbucks coffee, and I tell you that your first coffee of the day at Starbucks has 10 utils, then you can tell me a measurement of utils for maybe consuming a cookie or a croissant or something like that. So it is one way to measure utilities through utils. Another way is through dollars. I like dollars because we know what dollars are worth. And so I'll be doing both in this chapter. Now, when we have our measurement of utility, we have two numbers to look at. We have total utility and we have marginal utility. We have a lot of margins in this class, and the margin always looks at the change in the total. So if you consume one more apple, you spend one more hour at the beach, you will receive a certain amount of utility, and that would be the margin utility. And then your total utility is simply just a running total. So your total utility can actually be all your margin utilities added up. So you get the margin utility for, say, the first apple, margin utility for the second apple, for the third apple, and so forth. And then we have a law that drives your utility, and that's the law of diminishing margin utility. It's not an absolute law. There are some exceptions, but for most things it works this way. It's just a form of human nature that if you have that first cup of coffee of the day, that one seems to just taste better, has a better effect on your personality, it gives you a jolt of caffeine. The second cup of coffee might still be good, but it's never quite as good as the first. And the third cup of coffee, again, is not as good as the second, and so on. And eventually some people will decide they want to consume 3 coffees or 4 coffees or 5 coffees, but everyone is finding their margin utility is diminishing as they consume more coffees. So a quick example is right here. We have some ice cream, and the first ice cream a person consumes, say, is 20 utils, and that might be based on, say, a star coffee beans. And so given the star coffee is, this person has said, you know what, that's worth twice as much in terms of so I'll give it a 20. But no matter what number you start with the first one, the second one is going to be less, and it's going to keep falling. Eventually, you might even get to 0. Well, it will get to 0. And in fact, it might even be negative. If you go to the 8th ice cream, say within a 10-hour period or something, or 2-hour, maybe before dessert, you could have disutils. Make you get sick, give you a bellyache. And then your total utility is simply adding up the margin. So if you consume just one ice cream, you would have these 20 utils right there. And if you consume a second one, then you have 18 added to the 20. You don't lose the 20. You still got that first ice cream. You go for a second one, and that is going to be less than the first one, and you will add it together. So 18 added to the 20 is 38. And these are again utils. And then we consume the third one. It has 14 utils. Add that to the 38, and that would be 52. And then the fourth one brings in 10 utils. That would bring it up to 62. So your total utility is increasing, but at a decreasing rate. This is deceleration that we talked about a long time ago. It's still rising, but again, every time you eat another ice cream, it goes up by a smaller amount, and that's because of diminishing margin utility. The 5th ice cream adds 6. That would be 68. 7th ice cream, the 6th one adds 2. I'm not sure what I said here. The 5th one adds 6. 6th one adds 2, and that would be 70. And the 7th one does nothing. It would keep it 70. And if we did eat the 8th one, it would actually bring it down by 6, down to 64. So your total utility can decrease if we overindulge. So with one good, we can look at utility this way. If it's 2 or more goods, it becomes more complicated. And so what economists have done is we've developed a utility maximizing rule, and this is to maximize total utility of all the items consumed. And so this is used when we have more than one good, which is more realistic. And the idea is that you want to consume your goods in such a way that the last item purchased for each good returns the same amount of margin utility per dollar spent. And so down here we have an equation. We have the margin utility of good A divided by the price of good A is equal to the margin utility of good B divided by the price of good B for C, D, E, F, G, all the way through all the goods to Z, and even more so. And if you get this equation here where they're all equal, then you have maximized your total utility. You cannot do a better job. And even though I'm pretty sure no one in this class has ever seen this equation before, we do behave as if we are using this, because we do look at utility, we do get an idea of the benefit we get from things, and we do take price into consideration. And we want to take price into consideration because just looking at the margin utility is not a fair comparison. How much margin utility do you get from, say, having tickets to the Lakers game compared to tickets for, say, a local minor league club? Well, obviously the Laker game brings you more benefit satisfaction than a minor league club, but the minor league club price is going to be a lot less than the Laker ticket price. And so you want to compare the money you're spending versus the return you get. You're trying to maximize the return on your money. So a test question down here, let's say I tell you that the margin utility of A over its price is, say, 20 euros per dollar spent, and that's all we know. We don't know the price is. All we know is that per dollar we get 20 euros per dollar spent. And that would be on the last unit of A we're buying. Maybe we're buying 5A, and this would be the fifth one. And then we have the margin utility over the price of B, and this might be, I don't know, the sixth unit of B, doesn't matter. And getting 10 euros per dollar spent. So I don't know how much the dollars are, but I do know the dollars over here for A are getting twice the return than the dollars here. So what I want to do is I want to take money away from B and move it into A. Why? Because A is a better buy, and I'm trying to maximize the return on my money. But by doing that, I'll be driving down the margin utility of A, driving up the margin utility of the last unit of B I'm buying, because now I'm buying less B. And now I'm going to the fifth unit of B, the fourth unit of B. The price is staying the same, and so eventually this ratio will equal that ratio. And once they're equal, the margin utility of A over the price of A is equal to the margin utility, keep doing that, margin utility of B over the price of B, then I can't do any better. Say it's down to 15 euros. It would be 15 euros per dollar there, 15 euros per dollar here. They're both giving me the same return. I cannot redirect my money in any way that I can get a better return. I've maximized my return for both dollars being spent on B and dollars being spent on A, and therefore that's where I maximize my total utility. So test question, I can have something like this. And here I'm measuring margin utility in dollars. And so what we have here is we have a budget of $10 that we're going to spend on two goods. Price of hot dogs is $2 per hot dog. Price of sodas is $1 per soda. And so most of my $10 I can buy 5 hot dogs, which is why I stopped there. And at most I can buy 10 sodas, which is all the way down there. And these are my margin utility numbers for hot dogs and sodas, which I just made up myself. And instead of measuring them as euros, I measure them as dollars. And so this person likes hot dogs. The first hot dog they buy, they're going to get $24 of return benefit, but they only have to spend 2. And again, that would be a huge consumer surplus right there of $22. And then this combination of sodas and hot dogs will give me this budget line like this. Excuse the drop there, got some water on it, dried and it's stained. Don't want to print it out again, that'd be a waste of paper. And so we can go all the way to 10 sodas and $5, and so what I want to do is find the best combination here. I can start here, I can start there, I can start anywhere. To figure out the best combination, just pick a combination where we spend $10. So one combination I have right down here is 6 sodas and 2 hot dogs. That'd be 6 sodas is $6, 2 hot dogs is $4, $2 a piece. That's my $10. So one of the conditions of this problem is to spend all $10. And now I want to look at the margin utility of the last soda I buy over the price of soda. And we'll look at that, the margin utility of the last hot dog I buy over the price of hot dogs. Why the last one? Because if I'm going to give up a soda, or 2 sodas in this case, and buy another hot dog, or give up a hot dog to buy 2 sodas, the one I'm going to give up is the last one I'm buying. So if I'm buying here 2 hot dogs, if I'm going to give up a hot dog, is going to be the second one. I can't give up the first one without giving up the second one, because I still got the first one. And so I'll give up number 2 here. And if I'm buying sodas, I'm buying 6 sodas, I'll be giving up actually 6 and 5. So I want to look at the last soda that I buy, this one here, and compare it to the last hot dog here. And so the last soda brings in $6 of utility. It costs $1 to buy it. So that $1 is getting a return of $6. Here I'm paying $2, and the return I'm getting on that second hot dog is 20. So 20 divided by 2 is $10. So these $2 here are giving me $10 a return per dollar spent, and this dollar here is only giving me $6 of benefit utility. So what I want to do is I want to take money out of my sodas and move it over to hot dogs, because this is a better buy. And then I'll stop there and come back and look at the buying one more hot dog.